Hey there, 8th graders, and welcome to the Explainer. So today we are diving into a really powerful idea, how simple, everyday math equations completely dictate the future of lines. Seriously, by looking at just a couple of numbers, you can absolutely predict if two lines are going to walk side by side forever or if they'll crash into each other at one exact point. By the end of this, you are going to be an absolute pro at making those predictions. Let's get right into it.
Here's a quick look at our roadmap for today. We've got the geometry around us, parallel walking together, perpendicular intersecting perfectly, testing the slopes, your turn to practice, and finally, math, morality, and peace. Okay, let's dive into this and master the math before we tie it all back to a pretty cool life lesson.
Section 1. The geometry around us and why alignment matters. You know, geometry isn't just something stuck on graph paper or buried in a math textbook. The whole concept of alignment is literally everywhere in the real world. Now, the HeroesMart curriculum actually frames this mathematical theme using a quote from Amos 3:3, which asks, "Can two walk together unless they are agreed?" It's an interesting connection. Just like people kind of need to agree on a destination to walk alongside each other, geometric lines have to strictly agree on their path. If they don't, well, they either drift apart or they crash.
So what does all this matter to us? Well, understanding how lines interact is exactly what lets engineers build safe bridges and helps architects design those massive skyscrapers. It's literally the foundation of city planning. And hey, if you're into video games or animated movies, this is the exact same math used in computer graphics. But the curriculum actually takes it a step beyond the physical. It draws this parallel to spiritual life, explaining that just as parallel lines keep a consistent distance, individuals are encouraged to walk consistently with their spiritual and moral foundations.
All right, Section 2, Parallel, Walking Together.
So, the crucial point is this. Parallel lines will never, ever meet. No way. They can stretch on forever, way up and down a graph, but they will always keep their perfect distance. And why is that? Because they have the exact same slope. Think of the slope as their angle, their trajectory. If they share the exact same slope, they are perfectly agreed on where they're going. But, and this is a big but, they have to have different y-intercepts. That just means they start at different points on the y-axis. Because think about it, if they had the same slope and the exact same starting point, they'd literally just be the same lines sitting right on top of each other.
Moving right along, Section 3, Perpendicular, intersecting perfectly. Now, let's shift gears. Perpendicular lines are totally different. They actually cross each other to form exact right angles. We're talking those sharp, perfect 90-degree corners. But how do we know they're going to do this just by looking at the equations? Well, the secret key here is something called opposite reciprocals. Let's break that down carefully. To find an opposite reciprocal slope, you basically do two things. First, take the fraction of your slope and just flip it completely upside down. That's the reciprocal part. Second, you reverse the sign. That's the opposite part. So, if your slope is positive, make it negative. If it's negative, make it positive. Simple as that.
And this brilliantly illustrates the difference right here. Contrasting these two rules side by side is the absolute best way to lock them into your memory. For parallel lines, you're looking for a copy-paste scenario, identical slopes, which means they never intersect. But for perpendicular lines, you're hunting for that flipped and reversed number, the opposite reciprocal, which guarantees that perfect 90-degree crash. Keep these two golden rules of alignment in your back pocket.
Section 4. Testing the slopes. Let's actually put these rules to the test.
Okay, let's walk through these three mini-narratives step by step. Take a look at that top row. Our equations are y equals 3x plus 1 and y equals 3x minus 5. Remember, the number attached to the x is our slope. For both of these equations, the slope is 3. Since 3 equals 3, they are perfectly aligned. The verdict? Definitely parallel. Now look at that middle row. Our slopes are -2 and +1/2. Let's think back to our rule. -2 as a fraction is -2 over 1. If we flip that upside down, we get 1 over 2. Then we change the sign from negative to positive. Boom, we get a +1/2. Because they are opposite reciprocals, our verdict here is perpendicular. Finally, check out the bottom row. We have a slope of 4 and a slope of 3. Are they the same? Nope. Are they flipped opposite fractions? Nope. So these lines will eventually intersect, but just at some random awkward angle. The verdict for this one is neither.
All right, Section 5, your turn to practice.
Okay, you've seen how it's done, you know the definitions, and you've got the tools. So, are you ready to test the alignment of these equations yourself? I highly encourage you to grab a pencil and some paper for this next part, because doing this yourself is really how it's going to lock into your brain.
All right, here are your 5 practice pairs.
What I'd love for you to do is just pause this explainer in a moment and write these down. For every single pair, zero in on the number right in front of the x. Remember, that's your slope. Ask yourself, are they exactly the same number? If yes, jot down parallel. Are they opposite reciprocals, where the fraction is flipped and the sign is changed? If yes, write perpendicular. Or are they just two totally different numbers? If so, put neither. Go ahead, hit pause, and put your new math skills to work.
Welcome back. Let's wrap things up with our final section, math, morality, and peace. Let's look at the bigger picture here.
So this entire lesson aligns really nicely with the core philosophy of the heroesmartacademy Godly Learners series. They emphasize that education without morality will ultimately hurt. And if you think about it in the context of what we just learned, it makes a lot of sense. You could be a brilliant engineer who completely gets parallel and perpendicular slopes, but if you choose to use cheap materials or ignore safety rules, your bridge is still going to collapse. The curriculum is essentially asking, what's the point of being highly educated and smart if a person continues to make bad, unaligned choices that end up causing pain? Math has strict rules that keep structure standing, and the source text suggests that life has moral rules that keep our communities and our own hearts standing strong.
Which brings us right back to our starting point. The curriculum suggests that just as we look for perfect alignment in equations to find structure, spiritual alignment brings peace. It actually points to Romans 8:6-7, which promises peace of mind to those who keep their focus spiritual. So, according to this philosophy, when a person's moral foundation matches up with doing the right thing, the ultimate result is peace. As you go forward today, the source material leaves us with a final, really provocative question to consider. Not only how will you align your mathematical equations, but what kind of path are you choosing to walk in your own life? Thanks so much for joining me, and keep exploring.